Okay, the title of my talk is Shedding Light on a Dark Universe. Okay, so in this talk, when we're shedding light on a dark universe, which I'll explain in more detail, the first thing we want to look at is what is the role of physics? What do we mean when we're talking about physics or modern cosmology within physics as a whole? Then that will lead me to discuss what the tensions are in our understanding of the universe at this current moment. And does this open the door for consciousness to play a role in modern theories of cosmology? And from that, does that give us a nice opening into presenting the Vedic metaphysics? And one way to do that, building off of Akanadi's talk, is an appeal to the striking and compelling correlations between the two pictures. And I think this connection will spark some real curiosity for a general audience or the scientific-minded audience. And in this way, the way we think about it is using Shabda, or authorized verbal testimony, as an enhancement to science. Within the picture, what will set us apart is not just that there are two correlations, but rather that we can introduce a teleology to the modern scientific view. And there are a few forthcoming technical papers coming out about this topic, and we hope to distill them down into other presentations for the general audience through the BI. So please stay tuned for that, and you can ask me about it afterwards, and I can circulate the papers we're working on. Okay, so what is the role of physics, and where are we headed with all of this? So physics has to deal with experience, believe it or not. It's well understood that physics models the world as we experience it and not as it is. It's the consistent experience that we all have that we can model, and that's what we call physics. Now, back in the early 20th century, our friends Heisenberg and Bohr here in the quantum revolution gave the sort of idea that we may be co-creators in our own reality. It seemed to be that our own observation and intention had an effect on physical reality. We're over 100 years after that, but these ideas are coming back into the mainstream circulation. Now, in terms of purpose, meaning can be inferred from the scientific method, but it's not inherent therein. You can go out and study the cosmos mechanistically, but you'd be ascribing your own meaning to it. In terms of consciousness, contemporary physics is now revisiting old ideas, but in new contexts. For example, in computer science, how information can give rise to physical reality. These are ideas taken very seriously and posed by Nobel laureates. And there's other work in the field of philosophy, such as cosmopsychism and panpsychism, where the fundamental layer of physical reality is consciousness itself. So this is now in the mainstream discourse, a great opportunity for us to introduce our perspective. Okay, so what are the tensions in modern physics? Well, let's first look at the small scales, and I mean very small scales, 10 to the minus 35 meters, almost impossible to comprehend. At this level, we have sort of a sea of information. They're basically just fields of numbers and equations, but not necessarily ontological things. And as Stephen Hawking once said, we can get all the mathematics right, but what breathes fire into these equations? How do they do what they do? And the idea is that which we will get into is that the non-physical can give rise to the physical. Okay, so we've taken a journey to the smallest scales, but physics also has to look at the size of the universe, which is of order 61 orders of magnitude larger. So you're trying to connect one framework to cover all of this. And in astronomy and cosmology, what you do is you take a telescope and you take snapshots in time and you try to piece together an evolution. And what we found in the last 2 decades is that 95% of the universe is black. What I mean by that is that it's not 95% of the stuff, we don't know what it is. We see its behavior, for example, what's called dark energy, which is causing the accelerated expansion of the universe, and dark matter, which is having a gravitational effect on all the stuff we normally see, atoms and everything in our regular day life. So much of the universe we don't even know about. And that's why I'm saying it's a dark universe. But we can shed light on this. So where is this issue of the micro and the macro, the quantum world and the world of Einstein's relativity on the largest scales? Where is this really coming into conflict? This is your typical space-time diagram where, if you can see my cursor, this would be, we can consider sort of the beginning of the universe, and space is expanding as we go forward in time. So this is kind of the Big Bang model. And where this is going to be an issue is when we run the clock backwards from the very big today, an expanding universe, back to the beginning, you'll be in a realm where gravity and quantum mechanics will have to get along. And that's very problematic. That's a huge tension in modern physics. No one's been able to solve it. So there are many issues with this standard Big Bang model. This is, again, a space-time diagram where we start from some small state and expand out to today. And there is, for lack of a better word, a universe of models that address this problem, and many of which are completely contrived and ad hoc, but just try and solve the problems that arose in the simple Big Bang model. And a lot of these models, they fit the data, they fit the observational data, but they have wildly different ramifications for what the universe could be in the future, the past. Is it cyclical? Was there one initial start? Where did it all come from? And more importantly, if we go to this level, are these even testable? So if we're talking about things where our universe came from a previous universe, is that even the realm of scientific method? I would argue it's very much not. And what often happens is you get things like a multiverse, that you've probably heard of in normal modern cosmology, which is essentially just kicking the can farther down the road. It doesn't really give any explanatory meaning whatsoever. So let's consider one particularly interesting notion, and stay with me. It's a little far out, but I think you'll find it interesting. So for the astute scientist in the audience, maybe you can tell what this space-time diagram looks like of the universe. This looks like a familiar black hole. This is a black hole diagram. So if you just take our universe, it kind of resembles a black hole. A black hole is a space where you have something that is expanding, but then ultimately under the force of gravity collapses down in sort of a runaway collapse to perhaps a singular point. And the anatomy of a black hole, you have what's called an event horizon, where anything that passes beyond this sort of trapped limit can never come back out. So we can't see what's inside. If you were inside, how would you know you were even in it? You could never know what's inside. So it's generally modeled as sort of normal space as we know it. And then with inside of a black hole, we're not really sure what's going on. So could our universe be inside of a black hole? I realize it sounds very strange, but it could be quite reasonable. And I'll go on to explain why I'm choosing this one particular model to relate it to our Vedic metaphysics picture. So this has been thought about since the 1920s, especially Hawking derived in 1965 a way to think about the Big Bang as a black hole. So there's a rich history about this. So again, information can go into a black hole, but it can never come out. So how can we know anything about it if we were inside of one? And I should say that we actually have observational measurements and pictures of black holes in the universe. We know they exist. They're not just exotic things that we're speculating about. So one method is you can take what looks like kind of normal space on the outside, very kind of static, similar to what we experience here. And then on the inside, you would say, well, what if it's like our own universe as we know is expanding and rapidly expanding? Is there a way to connect what's inside with what's outside? And that's been the problem for decades and decades. But there's been some breakthroughs with that. So I'm going to talk about one particular model. It's the model of Gassenjager et al., 2021. And my nomenclature here is on the left-hand side, a black hole universe and a Vedic universe. So I'm going to do a side-by-side correlative conceptual picture, not literal picture, conceptual picture, just to guide you along. So building off of all the information Akhandati Prabhu gave us, we start with an information field. And in the black hole universe picture, that specifying information will be things like quanta, the spin, charge, all these things that make up the quantum universe. So we have a grid of this information field. In the Vedic universe, we have the gunas and the specifying information there. So we have a nice starting place. We're not saying they're ontologically the same things, but conceptually a good starting point. Now, as Akhanadi described, you perturb this field somehow. You agitate it, you mix it. So in the black hole universe side, this will be just like gravity and pressure waves. And this is a random process. But you see, you start to get sort of over densities of gravity. In the Vedic universe, Kala is doing its mixing. It's forcing the mixing of the gunas, and you get a same sort of perturbation to this field, where you'll have what we can say are over densities of information. The next step is that you can reach some sort of critical point where you've now made a trapped boundary. So as you can see, these will be what will ultimately be black holes. They've reached some sort of critical state where they will escape and just free fall collapse. And in our Vedic picture, these would be the Brahmanda coverings that are essentially providing a closed universe that is now manifest. So let's look at one of these particular overdensities. So I'm just taking one. We'll start on the left-hand side. That's just one of those bubbles you saw before. And it has some certain mass. Let's say it's the mass of our known universe. That will start to contract under gravity, okay? And at some point, you will form an event horizon. This is what traps the universe and doesn't allow anything back out. This will continue to collapse and collapse as black holes do. It will hit some critical point where it will no longer be able to support that inward pressure, and it'll shoot back out. And this is, you've often heard of as a big bounce. Okay, so as we go forward in time, it will bounce back out. This will lead naturally to a big bang scenario, and you will keep having this rapid expansion. And this will approach, once again, the event horizon. It will go back out towards it. Now, what's interesting in this scenario is that as you approach that boundary, it has an effect that exactly mimics dark energy, this mysterious thing that we don't know what's causing an outward pressure. It has all other effects where it also can explain dark matter, all the other problems with the standard Big Bang model, wrapped up in a sort of simple picture. Not saying this is the right one, but it is one that solves a lot of problems, and it has a very similar look to the Vedic universe. Okay, so going back to this picture of collapse and coalescence, remember that each one of these is a different universe in this picture. There's some information field in the black hole picture. We can't really say what it is. We don't know for sure because we live inside of one of these regions. That's not mine, I swear. And so this is in essence a multiverse situation. On the right-hand side, of course, we have the multiverse that we know in the Vedic picture. Again, a very strong correlation here. But a problem arises. Then what? Okay, fine. Maybe there's this mechanism for forming a black hole universe. But where do you go from there? Do black holes just evaporate? Are they nested in some sort of larger thing that we can never know about? It doesn't really get us anywhere whatsoever. Again, kicking the can down the road. But as Akhanadi showed, we have a very nice mechanism that we can go through this quiescent stage of pradhana that is sort of transempirical. It's outside of our normal empirical situation, but is a metaphysical picture for how you can dissolve an information field back and then create new universes. So this patches together a nice way to explain almost any modern cosmological model. And this is the missing piece where we're really trying to inject ourselves into the scholarly dialogue to give impetus for this. And this is the way to complete the causal loop. So here the Vedic picture is very similar to modern cosmological models, but it's not centered on random creation. Rather, conscious agency and intention impel all of this and keep it going. So it's a way to get from something that's just an information template and not a random process to form a universe. Rather, there's intention behind it. So this is a rich, metaphysically comprehensive, and I would say very comprehensible process for cosmogenesis. And it's a nice way to expand our knowledge by harmonizing Shabda and science. And going back to this idea of Hawking, this is what breathes fire into the equations. That's the piece that's missing. So we can synthesize empirical and transempirical knowledge to go beyond the fundamental limits of physical cosmology. Physical cosmology, we're not saying is wrong. We're saying it hits a boundary. Here's a way to go beyond that boundary. So in this way, the universe is no longer dark. Instead, it's infused with life and purpose and meaning. And there's a lot of exciting work here to be done. And hopefully I stopped early. Thank you. Any questions? I stopped 8 minutes. Yes. Right there.
Thank you again. Wonderful presentation. I can't decide which of the two questions to ask.
Neither is fine.
So you showed the parallels side by side of the Vedic universe and the one you were describing for physics. But in that one slide where it went from the big bounce to the Big Bang, there was no parallel. At least I missed it. Would you mind talking about the parallel here a little more?
Well, that's a great question. The parallel would be is that the Vedic picture. Oh, the question was here. I brought up this this image here, the schematic, and the question was, in this image where there is sort of a big bounce and a big crunch, what does that have to do with the Vedic picture? And to be explicit here, what I meant to say is that this is a model like other models that has a cyclic cosmology. So in this way, you have a contraction and expansion. However, in this one, it's not an eternal expansion and contraction. It's potentially just one of those. There are other models where it eternally expands and contracts. But that, yes, that is the connection, is that it's a cyclic model. Thank you for pointing that out. That's a great point. Yeah.
So I've also got. So if it goes from state where, it's going from, I guess, universe to big crunch, shouldn't we see that the expansion are like far off galaxies and whatnot are slowing down before they come all back together, which is not what you see or not always seen?
Yeah. The question was, as we approach, or we're going forward in time, as we see things crunching down, I should be careful how I say this, towards a big bounce, shouldn't we see galaxies getting closer or matter in general crunching down? But the point is that wasn't our universe. This is something that collapsed, a big bang happened, and then these things come into formation. So we weren't there for that previous epoch. This is the post-Big Bang epoch that we're observing, if that makes sense. And it's modeled as kind of the same way you would a star. So when you get down to super small scales, there's an outward pressure from the Pauli exclusion principle that shoots it back out. So it's a natural mechanism for that. And then we experience the universe after that Big Bang. Yes.
There's a question online.
Oh.
I don't know.
Can someone read it for me? Or I can, let's see. That's good. I'll take it online. Okay. If the scientists have captured the image of black hole, and by your comparison of Vedic and modern cosmological model says that black hole depicts other Brahmanda, are you implying that scientists have captured the image of another Brahmanda from this Brahmanda? No. This again is a correlation. There are different ways to think about it, because we know if this universe is a black hole and it contains other black holes, that just implies that there are nested universes within it. I am not saying explicitly that the Vedic universe picture is the black hole picture. I'm just showing a mechanism that we can use to correlate with modern cosmology, because this particular model could in fact be entirely wrong. So I don't want to stake my claim to that. It's just to show the parallels. Okay, I have a little bit more time. One more question. Oh, sorry, Ron.
I was gonna ask about, like this whole black hole model is based on this understanding that all the different stars are actually like suns, and you can see how their elements are redshifted to tell how fast they're going, and you can see their distances. But in the Vedic model, there's only one sun inside of Brahmanda.
Mhm.
So how can that fit into your
Well,
your theory?
I'm going to kick the can down the road. Oh, the question, yeah. So, the question was essentially dealing with the size of a Brahmanda being one solar system. How does it match with this picture of an entire universe in the modern cosmology sense, as being a correlation to that? And what I will say is later today or tomorrow, Dvija Govinda will be giving a talk about different ways to look at the size of a given Brahmanda, not necessarily just a solar system, but perhaps in other contexts. So that's a good way of dodging the question, but thank you. We have one more real quick. I have 2 minutes.
As perhaps the most lay person in this room, what does that model of yours tell us about the actual starting point or origin?
So the question was, what does this model tell us about the actual starting point or origin? It tells us nothing about it. And that's the point. It can't. Science can't tell us about that origin or point. That's why our metaphysical picture is ripe for the taking. Everyone should hear about it. Great question. Yeah, real quick, Laura, do you want to start coming up? And I think you're next. Yeah.
Maybe they asked the question and I didn't get it fully, but if we are inside a black hole, how is it that you know the boundaries? I mean, how can you see the thing is already fixed? If you're inside, how do you have reach to go to the outside?
Yeah, the question is, if you're inside, how do you know whether you're getting close to reaching the outside, if there is an outside? And the answer is really technical. It shows up in these anomalies in the maps of the early universe. So there actually are not just speculation, but predictions that you would see in astronomical maps that appear to be there, which gives some credence to this model. But we can talk about that afterwards. Thank you.